Alright everybody, in today's video we're going to get started working with the PyQt5 graphical user interface, also known as a GUI. In this topic we'll be creating a basic window. So let's get started. Alright, the first step is that using pip, we're going to install the PyQt5 package. Open up a terminal. Both PyCharm and VS Code have a built-in terminal that you can use. We're going to use pip, that is Python's package manager. Pip install PyQt5. Enter. And this might just take a second. Once your download has finished, you should have a package within your site packages folder named PyQt5. We can work with it as long as we import it. First, we are going to import the module of sys. Sys meaning system. This module provides access to variables used and maintained by the Python interpreter. Then, from the package of PyQt5, do pay attention to the capitalization. It's easy to mess that up. Use dot to access the module of Qt widgets. Widgets are the building blocks of a PyQt5 application. They begin with Q. That helps distinguish them from widgets from other libraries. They typically begin with Q. From this module, import the following widgets: Q application and Q main window. Here's some boilerplate code that we have to write in order to get this application up and running. First, we will create a class of main window, which will inherit from the class of QMainWindow. By inheriting from the parent of QMainWindow, we can customize our own windows to display to the user. We will need a constructor. Let's define that. Define dunder init. There will be no arguments currently besides self, and in case we have to pass any arguments to the parent of QMainWindow, we will access the superclass, that's the parent, and call the parent's constructor. But currently, we don't have any arguments to pass in. We will return to this class momentarily. Let's define a function of main. When we begin this program, we will call the function of main to begin the application. For now, I'll write pass. If we are running this file directly, let's add the following if statement. If dunder name is equal to a string of dunder main. If we are running this file directly, call the main function in order for us to begin. If that's true, we will call the function of main. Within the main function, we will create an app object. App equals, we will call the constructor for QApplication, that class. But there's one argument that we have to pass in. We will access our module of sys dot argv, meaning arguments. So by passing in this argument, this allows PyQt to process any command line arguments intended for it. That's if we use command prompt or terminal. We won't be doing that in this series, but you may someday in the future. It would be a good idea for us to future-proof our code. Otherwise, you may see people pass in an empty list. So we now have an app object. Next, we will create a window object. Window equals, call the constructor for our class of main window. Currently, we don't have any arguments to pass in. We have an app object and a window object by calling their respective constructors. Now, if I run this program currently, our window is not going to show. The default behavior for a window is to hide it. In order to show our window, we will access our window, call the show method to show it. It's only going to appear for a brief second when I run this script. I don't know if you saw it, but it pops up for a brief second. We need to ensure that the window stays until we interact with it or close it. After we show our window, we will access our module of sys, call the exit method. The exit method ensures a clean exit of our program. Within our exit method, we will pass in as an argument our app object. Our app object has a built-in method of exec underscore, and this is a method, so we can call it. This is the execute method. There is an underscore character after exec for execute. That distinguishes it from the execute method. There is a separate version of this execute function that ends with an underscore. Our app's execute method, it waits around for user input and handles events, such as if we click buttons, press keys, or close the window. Now that we're calling this method, when we run our program, this window should stay in place. We can maximize it, minimize it, or close it. That's all the boilerplate code that we need for a basic window. Let's customize it. Within our constructor for our main window, what would we like to add? Let's set the title for our window. Self.setWindowTitle method. We will pass in a string. Think of a title for your program. My cool first GUI. GUI. And now we have a new title. My cool first GUI. Graphical user interface. When this window appears, we can set the geometry of where the window appears and the size of the window. Access self.setGeometry method. There's 4 arguments: x and y for the x and y coordinates, a width of the window, and a height of the window. If I were to set x and y to be both 0, this window will appear in the top left corner of my screen. I'll also need a width and a height. Let's say, I don't know, 500 for each. So now, my window is now a square. The width and the height are both the same. They're both 500. The width is 500 pixels. The height is 500 pixels. With the first 2 arguments, we set the initial placement of our window to be where x is 0 and y is 0. That corresponds to the top left corner. If I set the first argument to be 100, well then the window is going to move to the right by 100 pixels. There are ways to center your window in the very center of your screen, but that's a little too advanced for us right now. For the time being, I'll pick something roughly near the middle of my screen. 700 pixels on the x-axis and 300 on the y-axis. It should appear roughly in the middle, but feel free to adjust these values based on the size of your screen. We'll discuss layouts in the future. Now, if you would like a window icon, we can change that. You will need an image to work with. So within my project folder, I have a profile picture for my YouTube channel. I'll set that to be the icon. Find an image that you like, then add it to your project folder. In order to work with icons, we'll need to make the following import. From PyQt5, that's the package, access the module of Qt GUI, import the following, Q icon. Now we can work with icons. After we set the geometry for our window, access this object of self, this main window, call the method of setWindowIcon. Within this method, we will call the constructor of QIcon. We'll pass in either a relative file path or an absolute file path. My main Python file is right next to my profile picture, that image. I only need the file name within a string. So the name of my image, it's going to be different for you depending on what the name of your image is. My image is named profile_pic, and this image is a JPG. Then when I run this program, I'm using my image as an icon for this window. Alright everybody, that is how to create a window using PyQt5. And in the next topic, we will be creating some labels. What's up everybody? In today's topic, we're going to create some labels using PyQt5. We will import the widget of QLabel. This label class is used to create label widgets that can display text or images. Within the constructor of our main window, this is where we'll create a label. We will declare a label object. Label equals, call the constructor for QLabel. For the text of the label, we'll pass in a string. That's the first argument. Let's say the word hello. For the second argument, we will pass in self. Self refers to this window object that we're calling and instantiating. Alright, let's do a test run. Here's my label, although you can barely see it. The font is really small, but it does say hello. Let's set the font. We'll need another import. From PyQt5 dot qtgui import qfont. By importing the qfont class, we can begin working with fonts. We're going to take our label, call the setFont method. Within this method, we will call the constructor of qfont. Pick a font that you would like. I will pick Arial, but feel free to choose really any font. Then the second argument is a font size. I'll pick 30. Let's do another test run. That's much better. Let's increase this to 40 for the font size. Now, I'm going to set the geometry of this label, such as the positioning and the width and the height. Let's take our label, use the setGeometry method. We will pass in x and y coordinates. 0, 0 corresponds to the top left corner. For the width, let's set the width to be 500 and the height to be 100. That's better. I'll cover more advanced alignments momentarily. Let's add a style sheet. PyQt does have styles that are very similar to CSS. If you would like to learn more about CSS, I do have a full course on that topic. We will add some CSS-like properties by accessing our label object, call the method of setStyleSheet. Within this method, we will pass in some CSS-like properties, such as a color. For the color, let's say blue. These CSS-like properties should end with a semicolon. And now the font color is blue. You could also use RGB values or hexadecimal values. You could always look up a color picker and pick a very specific color. Let's pick something green. We can either use RGB values or hexadecimal values. So I will copy this value. So I will paste that hexadecimal value. And now we have a very specific shade of green. But I think I'll go with something dark, such as that. So this color is going to be a dark gray color. We could set a background color. This will be a new string. Background-color. And I will pick a new color. I will pick something blue. That's a decent color. We have a blue background with dark gray text. We can set the font to be bold. Font weight will be bold. So the font is now bold. The font style can be italic. Font style italic. So our font is italic, and we can underline. Text, decoration, underline. The text on our label is now underlined. Let's work on positioning next. Currently my text is left justified and set to the center vertically. To work with alignments, we need this import. From PyQt5 Qt core import Qt. The class of Qt is used for alignments. To center the text of our label at the top vertically, we will take our label, use the setAlignment method, then pass in a flag, access the class of Qt, access the flag of align_top. This will align our text vertically to the top. So then, our text is aligned vertically to the top, rather than the center. For the bottom, we will use the flag of align bottom. We will align vertically on the bottom. The text is now on the bottom. To align vertically in the center, align V center. This will be vertically center, which it was originally. Now for horizontal alignment, we can add the following. Okay, to align right, we will pass in a flag of align right. Horizontally, align right. The text is now all the way to the right. For the center, align H, H for horizontal, center. The text is now horizontally aligned in the center. For the left, align left. The text will be aligned to the left. We could combine both horizontal and vertical positioning. Here's how. Take our label, call the set alignment method. We will align horizontally in the center. Follow this with the OR bitwise operator, which is a vertical bar. This allows us to combine flags. We will align horizontally in the center. Then vertically, let's align to the top. So our text should be aligned horizontally, we're aligned in the center, and vertically, we're aligned to the top. Align bottom, vertically. Horizontally, we are in the center. Vertically, we're aligned on the bottom. Then for the very center of our label, align horizontal center and align vertical center. Our text will now be in the very middle of our label, both horizontally and vertically. Now there is a shortcut for the very center. We don't need both of these flags. The shortcut is the following. Set alignment, align center. That will align the text both horizontally and vertically. So that is center and center. Alright everybody, so that is an introduction to labels in PyQt5. What is going on everybody? In today's video I'm going to show you how we can add images to PyQt5. You will need an image to work with. Me, I'll be using my profile picture for my YouTube channel. Feel free to take a moment to find a picture of your own. Maybe a profile picture of yourself. We will need the following imports. Q, label. The most common and straightforward approach to displaying an image is to add an image to a label in order to display it. Then we will need this other import. From PyQt5, that's the package, then the module of Qt GUI, import the class of QPixMap. The class of QPixMap, it's used for handling images and provides functionality for loading, manipulating, and displaying images. We will load our image to a QPixMap object, then add this QPixMap object to a label in order to display it. Within our constructor of our main window, we will create a label. Label equals, call the QLabel constructor, then pass in self. Self refers to the window object. Our window will be the parent widget. Our label widget is one of its children. Once we have our label, we'll set the geometry of the label. Label.setGeometry method. We have to pass in x and y coordinates, as well as a width and height of the label. For the coordinates, let's say 0 for each. The label will appear in the top left corner. For the width, 250 is good, and the height, 250 as well. Here's my window. The label is going to appear in the top left corner, however, there's nothing added to the label. That's where the widget of QPixMap comes in. we will create a pixMap object equals call the constructor of qPixMap. We have to pass in a string that represents a relative file path or an absolute file path to our image. My image is right next to my main Python file. I just need the file name. The name of my image is profile_pic, and this is a JPEG. When I run this, we don't see our image. We have to add the pixMap object to the label. We have to set it. Here's how. Take our label, use the setPixMap method, and pass in our pixMap object. And now we can see the image. However, the image doesn't scale according to the size of the label. To enable that, we have to call the following method. Take our label, call the setScaledContents method, then pass in true. Our image will now scale to the size of the label. If we were to change the size of the label, let's say it's 100 pixels, it will scale down even further. Or I could even increase it to 500. So now the image takes up the entire width and height of the window. Let's set that back to 250. There's a few tricks that we can do with positioning of the image. We've set our label with an image. We can move the label within the confines of the window. Currently it's set in the top left corner. But here's a few tricks that we can do with positioning. With our label, we will set the geometry again. So the top left corner is 0, 0 for the coordinates. We could pass in 250 and 250 again for the width and the height. But if we were to change that here, when we initially create this label, we would have to manually change that here as well. I think it would be better if we were to get the current width and height of the label. Take our label, call the width method to get the width. Same thing applies with the height. Label.height method. And that should work fine. Let's say we would like to take our image and move it to the right side of our window. Here's how. With the x coordinate, we're going to access self, that means our window, call the width method. Here's what we have currently. We can't see the label. It was placed outside of the confines of the window. Let's subtract our label's width. Label.width. I'll put each of these arguments on a new line just to help with readability. So now our image is right justified within our window. For the bottom right corner, we will take the second argument, access self.height, that's the height of the window that we're instantiating, minus our label's height. And now our image is in the bottom right corner. For the bottom left corner, we will set x to be 0. Now here's the tricky part. To have our image placed in the center of our window, we will take the width of the window minus the width of the label divided by 2. For integer division, we'll be using double forward slashes. We need our pixels to be whole integers, so we're going to be using integer division and not standard division. We will round to the nearest whole pixel. Then we will do this with the height as well. And now our image should be in the middle of our window. Alright everybody, and that is how to add an image to your PyQt5 application. Well, hello again friends. Today I gotta explain layouts in PyQt5. We'll discuss vertical, horizontal, and grid layouts, but we'll need the following imports. We will be importing QLabel, QWidget. I'm gonna put these imports on a new line just because we have a lot. QV for vertical, box, layout, and I'm just gonna copy this. QH for horizontal, box layout, and QGrid layout. Let's be sure that we have all these imports. These classes deal with layout managers. They aren't widgets. We'll be writing a majority of the code within our main window class. However, it can get disorganized really quick. What will help keep things organized is if we declare a separate function within the main window class. This is a common practice that you'll see within PyQt5. There will be a function for init, for initialize, UI, for user interface. No other arguments besides self. And for now, I'll write pass. When we construct a window object, we will call self.initUI to initialize the user interface. So anything that deals with the user interface, we're going to be writing within this function to help keep our code clean and organized. Normally, we can't add a layout manager to a main window object. Main window widgets have a specific design and layout structure that's normally incompatible with layout managers. What we would need to do is create a generic widget, add a layout manager to that widget, then add that widget to the main window in order to display the layout. Within our method to initialize our user interface, we are going to create what is called a central widget, called the constructor for QWidget. This is a generic widget. Then we will take self. Self is our window. Call the set central widget method. Then pass in our central widget. When working with layout managers, we will add that layout manager to the central widget. The central widget is then added to the main window. So currently, this is what we're working with. We will need some widgets to organize, because right now it's empty. Let's create a few labels. Let's say label1 equals QLabel. I'll pass in some text. Number 1. Okay, let's create 4 additional labels, 1 through 5. I'll just do some copying and pasting. All of our labels are overlapping. Let's add some colors. Let's take label 1, use the set style sheet method, then pass in a background color as a CSS property. Background-color will be red. Let's copy this line of code, paste it 4 additional times for labels 1 through 5. We'll have a label that is yellow, another that is green, blue, then purple. Here are the labels. They're all overlapping one another. That's why we can only see 5. This is where a layout manager comes in. We'll start with the vertical layout. We will create a vertical layout manager, which we will name VBox. VBox equals, call the constructor for QVBox layout. We are calling the constructor. We will take our layout manager, call the add widget method, then pass in a widget, such as label 1 near the top here. We'll do this with the other labels. We'll do some copying and pasting. Add label 2, 3, 4, and 5. There's one last step. We will take our central widget, which we have declared at the top of this function, call the set layout method. We are setting the layout of our central widget with the layout manager of VBox, vertical box. Here's the new layout. All of our labels, all of our widgets, are arranged vertically. For horizontal, we will use QHBox layout for horizontal. Replace any instance of VBox with HBox. For the set layout method, pass in HBox. This allows for a horizontal layout. Then we have grid. QGrid layout. Replace HBox with grid. So what we have to do with grids, after adding a widget, we have to specify a row and column with separate arguments. The row and column both begin with 0. So row 1, column 1 would be row 0, column 0. For label 2, let's say row 0, column 1. Label 3 will be row 1, column 0. 4 will be row 1, column 1. Then 5, row 1, column 2. So here's the current layout. We have labels 1 and 2, both within row 0. Labels 3, 4, and 5 are both within the second row. Let's say label 5 is row 2, column 2. That would result with something like this. We have label 5, which is purple, in row 2, column 2. So it depends on how you want to arrange your widgets. Alright everybody, so that is an introduction to layout managers in PyQt5. Today I'm going to show you how we can create push button widgets in PyQt5. To begin, we will need the following imports: Q, push, button, as well as Q label for this demonstration. During the previous topic on layout managers, within our constructor for our main window, we defined a method of initialize UI for user interface. Let's be sure that we're calling that method within our constructor. Within this method is where we'll be handling managing the user interface. To create a button, we will call the push button constructor. Normally when creating widgets, we would want to prefix that widget with self, then follow the name of the widget, for example, button. However, I'm going to demonstrate what happens when we don't do that, because without self, we're declaring a local variable. We'll get back to that in just a moment. Let's create a local button object by calling the QPushButton constructor. We can pass in some text, such as click me. We will add this to our window. Self. Self refers to our window object. Let's set the geometry of the button. Button.setGeometry. We could use a layout manager, but I do want to keep this lesson as simple as possible. So let's pick some coordinates. I've picked the following. For the x and y coordinates, 150 and 200. For the width, 200, and the height, 100. Here's our button currently. The font is a little small, so I'm going to set the style sheet. Set style sheet. I'll just increase the font size. We could use Q font, but that might be overkill for this demonstration. Let's just say the font size will be 30 pixels. Now we can read it. So we have our button. We're going to be connecting our button to a function, but we need to define that function. We'll do so within our main window class. So we will define a function of onClick. There are no parameters besides self. When we click on the button, what would we like to do? Let's print a test message. Let's say button clicked, and that's it. When we click this button, nothing happens. We have to set up a signal and slot for the button. Here's how. We will take our button, dot, list a signal. A signal is emitted when a widget is interacted with. We have to list the type of signal. So the signal we're looking for is clicked. When we click this button, we will perform a slot, an action. We will take the signal of clicked, connect it to a slot. Connect is a method. The slot will be self dot the name of the method, onClick. When we press this button, we perform this slot, this method of onClick. Each time I press the button, we perform that action. Not only should we print a message for this demonstration, let's set the text of the button. So we have button.setText. Let's change the text to clicked. So this actually isn't going to work because we're not prefixing self. Let me demonstrate what happens. We print button clicked, but then we have a problem. We have an exit code. Our program was interrupted. Button is considered local to our initializer method. Our onClick function doesn't recognize what our button is. That's why we're going to prefix our button with self. So it belongs to the class of main window, and not this method. Any instance of button we're going to prefix with self. And now this should work. The text on my button is going to change when I click it. Clicked. You don't have to do this, but with my personal coding style, whenever I create a variable or an object within a class, I like to do so within the constructor. Even PyCharm is giving me a warning. When we declare this button, I'm going to move it to the constructor. And let me just rearrange everything. Self.button equals a QPushButton widget. Within my initializer method, that's when I like to rearrange everything and style it. We can also disable buttons when we click on them. To do that, we will take self.button, call the setDisabled method, then pass in true. When I click the button, it will be disabled. I can no longer click on it. For the last part of this demonstration, when we click on our button, let's change the text of a label. Let's declare self.label within our constructor equals a QLabel. The text of the label will be hello. We will add this label to self, the window. When we set up the user interface, let's set the geometry of the label. Self.label.setGeometry. We could use a layout manager, but just to keep things simple, I'm going to set some coordinates. 150 for x, 300 for y, the width will be 200, and the height 100. Let's change the font size. Self.label.setStyleSheet. I will set the font size to be 30. Maybe 50. Better. Alright, within our onClick function, let's instead take self.label.setText method, then pass in some new text to display. We're saying hello, but when we click the button, let's say goodbye. So now, when I click the button, we will change the text on a separate widget, my label, which now says goodbye. So, with buttons, you need a signal that's connected to a slot. The signal is an event. The slot is an action that this widget is going to take when this signal occurs. And well, everybody, that is an introduction to push buttons in PyQt5. Hey, so today I gotta explain checkboxes in PyQt5. To work with checkboxes, we will need the following import. From the module of widgets from PyQt5, import QCheckBox. To work with different states, we will also need the following import from PyQt5.QtCore, import Qt. This module of Qt-Core, it contains non-GUI classes relevant to PyQt5 applications. So be sure that you get this import as well. To create a checkbox, I will create this within the constructor of my main window. We will create a checkbox with self, the name of the checkbox, which I will name checkbox, equals, call the constructor of the QCheckbox class. The first argument is going to be the text of the checkbox. What do you want the checkbox to say? Let's ask, do you like food? The second argument is the parent widget, where we will be adding this checkbox. Let's say self. Self will apply to this window. We could use a layout manager, but I want to keep this lesson as simple as possible. We're just going to focus on checkboxes and their functionality. So we should have a checkbox. However, we can barely see it. The font is really small. I have a method to initialize the user interface. That's where we'll set the style sheet and the geometry of our checkbox. Let's set the style sheet. Self dot the name of the checkbox, checkbox dot set style sheet method. Then we can pass in some CSS-like properties. Let's set the font size to be 30 pixels. And I will pick a font family. Font family Arial. Oh, and we should change the geometry of the label. It's getting cut off. Self dot the name of the checkbox, which is checkbox. Let's set the geometry. Pass in some X and Y coordinates for the placement, as well as a width and a height. I will pick 500 and 100. Maybe I'll move it a little more to the right by 10 pixels. That's pretty good. Our checkbox has an initial state. It's normally unchecked. That's the default behavior, but we could set that to be checked with the following method when the window loads. Let's take our checkbox, self.checkbox, call the setChecked method, then pass in true. So then when the window loads, the checkbox is already checked. But let's keep that as false. Now this checkbox, it doesn't do anything when I check it. Let's add some functionality. We'll take our checkbox, connect a signal to a slot. The slot can be a function or a method. Let's define a method within our main window class. Let's name this method checkbox changed. We will call this method when the state of our checkbox changes. There is one parameter besides self, a state. Now, the state parameter is going to be provided to us when we interact with our checkbox. When we check the checkbox, let's print something, like a test message. You like food. We have to connect a signal of state changed to a slot of checkbox changed. We will take self dot the name of the checkbox, which is checkbox. The signal will be state changed. To connect a slot to a signal, we use the connect method. Then pass in a function or method name. So we are working with methods. This method belongs to the window class. We'll prefix the method name with self. Self.checkboxChanged. So when I run this program, when I check the checkbox, we execute this method. You like food. Now when I uncheck it, I instead would like to display you do not like food. So that's where our state is going to come in. I'm going to print our state just to see what it is. Our state is going to be a value. When we check the checkbox, our state has a value of 2. When we uncheck it, it has a value of 0. 0 means unchecked, 2 means checked. There's also 1 for partially checked, but that's not going to be relevant to this topic. So 0 or 2. We could add an if statement such as if state is equal to 2, then print you like food. However, that's not really readable. Other developers looking over your code aren't going to understand what 2 is by looking at it. Instead, let's use the following. We will access the class of Qt. There's a built-in constant of checked. This also equals 2, but it's more readable. It's a constant. So if state is equal to Qt checked, print you like food. I will check the checkbox, you like food. When I uncheck it, nothing happens. Let's add an else statement. Else, let's print you do not like food. So then, when I check the checkbox, we print you like food. When I uncheck it, we print you do not like food. You like food, you do not like food. You like food, you do not like food. Alright everybody, so that is an introduction to checkboxes in PyQt5. Alright, let's do this thing. Today I gotta talk about radio buttons in PyQt5. To work with radio buttons, we will need the following imports. From the module of Qt widgets, we will need the class of QRadioButton, as well as QButtonGroup, to group together different buttons. Let's create 3 radio buttons. Within the constructor of my main window, we will construct 3 radio buttons. For the first radio button, this will be named radio1. We will call the constructor of the class QRadioButton. Then we can pass in some text. What is the radio button going to say? Let's say that we're working with payment options. Let's say Visa for the first option. Then for the second argument, I will pass in self. We will add this radio button directly to our window. That would be self. Let's create two more additional radio buttons. Radio 2 and Radio 3. The text of radio button 2 will be MasterCard, and 3 will be a gift card. We are selecting different payment options. We need to set the geometry of these radio buttons because we're not using a layout manager. I have a method to initialize my user interface. This is where I will set the geometry of my radio buttons. So let's say self.radio1. We will call the setGeometry method, pass in some coordinates. 0, 0 is good. That applies to the top left corner of my window. For the width, 300, and the height, 50 is good. Let's do this with radio buttons 2 and 3. Radio 2, Radio 3. We'll just move each radio button down on the y-axis by 50 pixels each. So 50, then 100. Here are the 3 radio buttons. However, the font is kind of small, we can barely see it. So let's apply a style sheet. Here's a trick that we can do with style sheets. We can apply multiple CSS-like properties to an entire group of widgets, rather than having to type them and apply them individually. We will select our window of self, set the style sheet of our window with the setStyleSheet method. We will add a selector. The selector is going to be the name of the widget. QRadioButton in this case, then add a set of curly braces. We can apply CSS-like properties to an entire group of widgets this way. So let's set the font size of all radio buttons to be 40 pixels. Better. Let's set the font family to be Arial. Then I will add a little bit of padding around each radio button. Padding 10 pixels. That's pretty good. So with radio buttons, we can only select one from any one radio button group. If I was making a payment, I can't pay with a Visa and a MasterCard at the same time. I can only select one option. That's the point of radio buttons. We're limited to just one option. With the default behavior of PyQt5, all radio buttons, unless explicitly stated, are all part of the same group. To demonstrate that, let's create two additional radio buttons, Radio 4 and Radio 5. Radio button 4 will be for a payment method rather than a payment type. For example, we could say we're paying in store. Radio button 5 will be we're paying online. Radio buttons 1 through 3 will be for the payment type. Radio buttons 4 and 5 will be for the payment method. We're either paying in store or we're ordering something online. We do need to set the geometry for these two radio buttons. I'll just copy these two lines, add Radio 4, Radio 5. We'll set the y-coordinate of 4 to be 150 and 5 to be 200. All radio buttons will be within the same button group. If I was to select In Store, we deselect one of these options. What I would like is one option from this first group and another option from this other group. These buttons are all in the same group. I can only select one. If I would like to pay with a Visa in store, and I click the In Store radio button, we unselect the radio button for Visa. I would like these radio buttons within different groups. We need to create two different groups and add them accordingly. Here's how. Within our constructor, we will access self, declare a button group. Let's name it button group 1 for simplicity, equals, call the constructor of the class QButtonGroup, then pass in self to set the parent widget to be the window. Then we will create button group 2. We're going to access self, select the radio button group, button group 1, call the add button method, then pass in a radio button. Self.radio1, then we'll add radio 2 and radio 3. We'll select button group 2 this time, button group 2, add radio button 4 and radio button 5. The first 3 radio buttons are within the same group. Radio buttons 4 and 5 are within a different group. We can only select one radio button from any one radio button group. Maybe I would like to pay with a Visa card in store, or a MasterCard online, or a gift card in store. These radio buttons are within different button groups. We're limited to one selection in any one radio button group. When we select these radio buttons, they don't quite do anything. For each radio button, we have to connect a signal to a slot. Here's how. Let's define a method of radio button changed. There will be no parameters besides self. Temporarily, I'll write pass. We'll fill this in a moment. We will take each radio button. Let's start with radio 1. Radio 1, the signal will be toggled. When this radio button is toggled, we will connect a slot. We will pass in a function or a method, self.radio button changed. Then we will do this with the other radio buttons. 1 through 5. Let's print a test message. You selected something. Just to be sure that everything is working. You selected something. Okay, we know that that works currently. What we're going to need to do is get the sender widget, which radio button sent the signal of toggled. I will create a local radio button to store that radio button, whichever one emitted the signal. We can determine that with self.sender method. The sender method is going to return the widget that sent the signal. So if we select radio button 1, our radio button will be radio button 1. If it was 5, then it's 5 in this case. Then we'll determine if our radio button is checked. Take our radio button, use the isChecked method. This will return a Boolean, true or false. If it's checked, if this returns true, then let's print the following. I'll use an F string. We will get the text of the radio button. Radio button, call the text method to return the text of the radio button. Is selected. All right, then let's see if this works. Let's select Visa. Visa is selected. MasterCard is selected. Gift card is selected. In-store is selected. And online is selected. That's how to determine which radio button was selected. Which one is the sender? Which one sent the signal? Alright everybody, so that is an introduction to radio buttons in PyQt5. Why, hello everybody. Today I gotta explain line edit widgets in PyQt5, also known as text boxes in pretty much anything ever made ever. Why are they called line edit widgets? I really don't know. Let's begin. From the module of Qt widgets, we will import the following class of Q line edit. To create a text box, I mean a line edit widget, we are accessing our window of self. We will call this line edit widget line edit equals call the constructor of the class QLineEdit. Then we will pass in self to add this line edit widget to the window. Let's set the geometry, but we do have a text box in which we can type in stuff. I have a method to initialize the user interface. Within this method, I will access self.theLineEditWidget and set the geometry. Let's set it in the top left corner where x is 10, y is 10, set a width, 200 is good, and a height, 40. That's not too bad. Now the text is really small. We can change that by applying a style sheet. Access our window with self, access our line edit widget, then call the set style sheet method. We can pass in some CSS-like properties, including a font size. Let's pick 25 pixels. And here's my new text box. We can read the text now. Let's also change the font family. Font family, I will pick Arial. This text box by itself, it really doesn't do anything. We need some way to get the text from the text box. Let's add a button. When we click on the button, we will get the text from the text box and do something with it, because right now it doesn't do anything. We will need to import qpush_button. Let's create one button, self.button equals, call the constructor of the class qpush_button. Let's say that this is a submit button. I will pass in a string of submit, and we are adding this button to our window. And we do need to set the geometry of the button. We're not using a layout manager right now. Access our window with self, access our button that we have previously created in our constructor, then call the set geometry method. We'll place our button where x is 210, y is 10, the width will be 100, and the height will be 40. Not too bad. Let's change the font size of the button. I'll copy these 2 lines of code because I'm lazy. Instead of selecting our line edit widget, we will select our button. That's better. If I were to click on the button, it doesn't do anything. We'll set up the signal of clicked to connect to a method that will do something. Let's define a method of submit. We're submitting something. We're submitting the text within the text box. And for now, I'll write pass. We'll get back to this in a second. We're going to take our button, self.button. We'll connect the signal of clicked.connect method. We will connect the method of submit, self.submit. So when we click on the button, we will call this method. Let's print a test message. You clicked the button. Let's type in something, press submit, and we get our test message. You clicked the button. Let's get the text from the text box, then do something with it. Let's create a local variable of text. Text equals, now we have to get the text from our line edit widget. Self.line edit, that's the widget. To get the text, we can use the text method to return the text. Then let's print the text. I'll use an F string. We'll say hello, add a placeholder, then display the text. So now, after typing in something, why don't you type in your name? Then press submit. We will display hello, your name. You could add some placeholder text too. Let's do that here. Let's take self.lineEdit widget, set placeholder text, and let's say enter your name. When I run this program, we have some placeholder text that says enter your name. This time I will type in SpongeBob, then press submit. Hello, SpongeBob. Alright everybody, so those are line edit widgets, also commonly referred to as text boxes. And well everybody, those are line edit widgets in PyQt5. Hello everybody, so in today's video I'm going to explain setting style sheets in PyQt5. CSS means cascading style sheets. If you're not familiar with CSS, you can still follow along, but knowing CSS is helpful. As a reminder, I do have a full free course on YouTube on HTML and CSS if you would like to learn more. Let's begin. For this demonstration, we will need the following imports. We will be designing some buttons. We will import QPushButton. We'll be working with the layout manager. We will import QWidget. And for a horizontal layout manager, we will need QHBoxLayout. So import these three from the module of Qt widgets. Now in previous topics, we've set the geometry of our window. Since we're using a layout manager, we don't necessarily need that anymore, so I'm going to delete it. In the past, I have also created a method to initialize our user interface, and we are calling that within the constructor of our main window. We will create three push button widgets. Self.button1 will be the first button, equals, take our QPushButton class and call the constructor. We can add text to the button. We will pass that as an argument. Now, since we're using a layout manager, we don't need to add this button to self, our window. We don't need to do that. Let's create two more buttons. We'll have button 2 and button 3. Button 2 will say number 2, button 3 will say number 3. Now we'll create a layout manager. Under normal circumstances, we can't add a layout manager to our main window. With main window widgets, there's already a specified layout and format. We're going to add a layout manager to a central widget, and this widget will be added to the main window. Let's take care of that within our initialize user interface method. We will create a central widget equals call the constructor of QWidget. Then we will take self, that means our window, and set the central widget. Set central widget. Then pass in our central widget to set it. Then we will create a layout. We will call the constructor within the class of QHBoxLayout. Let's name this layout HBox for a horizontal box. Equals, call the constructor within this class. We will take our layout of horizontal box, then add the following widgets. Add widget self.button1. We'll do this with 2 and 3. Then the last thing we need to do is take our central widget, call the set layout method, then pass in our layout manager. And now we should have those three buttons. They're all arranged horizontally. Now we're going to apply some CSS-like styling using the method of setStyleSheet. Here's how. Rather than apply the CSS properties individually, such as self.button1.setStyleSheet, and in the past we've passed in individual CSS properties, we're instead going to set the style sheet of our window, self. We have a lot to write. Instead of double quotes, we're going to use triple quotes. Triple quotes are used to write very long strings in a more organized way. All of the CSS properties that we're going to write are going to be within this set of triple quotes. So let me give you a demonstration. We could individually apply CSS-like properties to each of these widgets, but we could select an entire class of widgets too. Let's select the class of QPushButton, then add a set of curly braces. The following CSS properties will apply to all QPushButton widgets. So currently, this is what we have. We'll increase the font size for every push button. So we will add the following property of font size, then set it to be 40 pixels each. Be sure to end each CSS property with a semicolon. So the font size is now 40 for every button. Let's set the font. Font family, I will pick Arial. Let's add some padding. We can add some space around the text and the button itself. So with padding, if I was to set this to 75 pixels, we would have 75 pixels worth of space between the text and the border of the button. I would like to change the dimensions of the padding. So let's apply 15 pixels to the top and bottom of the button and 75 to the sides. That's better. Margin is the space around a button. Let's set the margin to be 25 pixels. Now the buttons are more spread out. If this was 250, they would really be spread out. That's margin. It's the space around a widget. Let's set that back to 25. I'm going to change the border. Border 3 pixels solid. This would change the border of the buttons. We now have a black border that's 3 pixels in width. If you would like to round the corners, we can use border radius. I will set that to be 15 pixels. With all the buttons, the corners are now rounded. Within our setStyleSheet method, we're applying all of these CSS-like properties to every push button. Now, what if you would like to apply CSS properties to only one widget, rather than all of them? Here's how. With each of our widgets, buttons 1, 2, and 3, we need to set an object name. Let's do that before we call the setStyleSheet method. We will take our buttons, self.button1, call the setObjectName method, then pass in a name for this widget. We'll keep the name the same as button 1. So let's do this with button 2 and button 3. Button 2, button 3. Within the context of setStyleSheet, we will refer to these widgets by their object name, buttons 1, 2, and 3. And now we can select them individually. Let's say that with button 1, I would like the background color to be red. We're going to access our class of QPushButton, follow this with a pound sign. I'd like to call it a hashtag. Then we need the object name. Button 1. Button 1 refers to the widget of button 1. Again, I kept the name the same. Then we need a set of curly braces. Between the set of curly braces, we can list one or many different CSS properties. Let's change the background color. I will set it to be red. And now the background color of only that button is red, and not all of them. If I was to set the background color within the class, well then, all of them would be red. Okay, so with button 2, I'll just copy what we have and paste it. We are selecting the ID of button 2. Let's set the background color to be green. So then the background color is now green. And button 3. Button 3 will be blue. If you would like a greater variety of colors, I recommend looking up a color picker. You can just Google color picker. So if I would like a very specific shade of red, I can pick that. Let's go with that. There are a few options provided to you. You can use hex values. Now we have a very specific shade of red. You can use RGB. RGB, enclose it within a set of parentheses, and then paste those numbers. Or my favorite, which is HSL. HSL means hue, saturation, and lightness. We will enclose our values within HSL. If you copy these values directly from Google, you would have to remove this degree symbol. I like HSL because I can also control the saturation and the lightness pretty easily. Okay, let's pick a very specific shade of green. That's good, I would say. I'll use the HSL values. HSL, remove the degree symbol, and now we have a very specific shade of green, and blue. That's good, I would say. That's not too bad. If you're already familiar with CSS, we can apply pseudo-classes, such as when we hover over one of the buttons. Here's how. Let's copy these 3 blocks, then paste them again. We can add CSS properties when we hover over something, we have to use the hover pseudo class. After the ID of each of our buttons, we will add :hover. We can apply the following CSS properties when we hover over the buttons. All I'm going to do is up the lightness, let's say by 20% each. Then when we hover over one of the buttons, the lightness is going to change. We apply the new CSS properties. Alright everybody, so that is a more in-depth explanation of the set style sheet method in PyQt5.